Hi everyone, welcome back. Today we're going to be learning about a new type of model called a random forest. So far we've been using what's called the decision tree model, which breaks it up into a single decision tree that we try and maximize it by changing the leaves. We can do some stuff to make it better. Today we're going to learn about random forests. So what this does is, the nice thing about decision trees is they're super easy for the computer to run. So you can train them and predict with them in thousandths of a second. So it's really a super easy model to work with. Sometimes models are more complicated and they'll take minutes, hours, days, weeks to train them. And then they'll be slow to use when you're processing data. It might take a while to use it as well. That's not true for forests, or for trees, I should say. The drawback of trees is they're not super predictive. They're pretty good, but they're not great. We've noticed that we've gotten within only tens of thousands of dollars of the correct answer on our data so far. Okay, so today we're going to learn about random forests. The difference in random forests is because decision trees are so easy to do, random forest runs a whole bunch of different decision trees with lots of different settings, and then it averages together all of that stuff, and it generally produces a better result without having to go through and tweak anything like leaves or anything like that. There is some tweaking you can do on random forests, but usually it works really well right out of the gate. And we'll learn more about the tweaking late in the next lesson. All right, so a lot of this is going to be the same thing that we've done before. So we are going to import pandas. We're going to import our file. We're going to convert it using read CSV from a CSV file to a data frame called Melbourne data. We're going to pull out our Y data. Oh, and this step here, remember, we don't do this on our data. This is just because the Melbourne data has a bunch of missing pieces of data. So we first go through and drop all the houses that are missing data. So that's this drop in A. Then we tell it what the Y data is going to be, so what we're trying to predict. So we're going to pull the price column out of the Melbourne data frame and store it in a list called Y. So now Y has all the values of the houses, or the sale prices of all the houses in the main table. Then we're going to decide what items that we're going to be predicting with. So we're going to use these as our features. And we're going to pull those out of that main data set as well. So we do Melbourne data, that's the main data frame, and we tell it, go find all of the Melbourne features, all of this list of columns, and take all those columns and store it in a new data frame called X, capital X. All right, now we need to we need to split our data into training data and testing or validation data. And we use the, from sklearn, library, we use the train test split function from there, and this function is going to take all of our big X, our big data frame with our features in it and our prices, and it's going to split them up into a train X, train Y, validation X, validation Y, so 4 groups from 2. Okay, let me run that real quick, and while we talk about the next bubble, we can, whoa. Oh, I can't run this. Never mind. This is just an image of the data of the code. I apologize. So that's all stuff we've done before. Nothing new there. So once we've broken it into training and validation, we're still doing that. We're going to actually import the random forest generator instead of the decision tree regressor model. And we're going to still bring in that mean absolute error. We're going to be calculating how far off we are in the same way we did before. So the first thing we do, just like before, we create our model and we store it in a variable. So instead of using decision tree regressor here, we're using random forest regressor. And again, we're setting the random state to equal to something so that every time we run this bubble or rerun this bubble, we get the same results because it's starting in the same random state. And then next thing we do is we take that blank model and we fit it using our train X data and the train Y data. So now it's building out. The difference here is this fit isn't going to just build one tree. It's going to build a whole bunch of different trees with different properties and settings and organized in different ways, and then average together the values for all the houses that it spits out. So it might make 20 predictions for the same house, and then each of those trees will they'll average out those 20 predictions into one prediction. All right, and now once we have it fit and trained, we have our model ready to go, we can do predictions. So we do forest model dot predicts val x. So this is this validation data. Our model's never seen these houses before, so we're going to really see how it works, how well it works. It's going to take all of those room numbers and square footage and all that feature data, predict the value of those houses, and save those predictions in a list called MELB PREDS. Now we just need to calculate our mean absolute error. So we take our mean absolute error function, we say, okay, here's the actual value of the houses, and here's our predicted value. It's going to subtract those, take the absolute value, and then find the average of all of those from everything. And here, when we do this, we get 191,000, which without messing with anything like leaves or any features of the random forest, we've improved it from 250,000 before, all the way down to 191 just by using this random forest and having this averaged of a bunch of different trees averaged together. All right, that's the first part, that's the lesson. That's all we're doing is just using a different model. So let's go ahead and deploy that using the exercise. So here's exercise 6. Taking a little bit to load. Yay, internet. All right. So this is the exercise for lesson 6. And you can see here we're doing that same import. We're importing pandas as PD, so we're doing that for data collection. We're going to import the mean absolute error for calculating how far off we are. Train test split to split our main data into 2 categories of training data and validation data or test data. And we're going to import the decision tree regressor start with. We'll import the random forest down below, but the first thing we're going to do with this first set of code is go back and remind ourselves with decision tree regressor, both without setting the number of leaves, the maximum leaves, and with setting the maximum number of leaves, what kind of mean absolute error we get, so we can compare that to the random forest below. So again, we've got our file location here for all of our data. We import that using the pandas read CSV function. That's going to convert that from a CSV file into a data frame called home data. So now all 1,400 houses are being stored in the home data along with all of their information, price and square footage and all of those different things. If we were doing this for real at this point, we would want to do something here where like home data dot describe, home data dot columns, so we can see what the exact name of the columns are. And from those columns, we're going to pull out the sale price. And we're going to say, okay, the sale price goes in Y because that's what we're trying to predict. So we create a variable called Y. We told the computer to go to the home data, that huge data table, pull out the column called sale price, and store it in the list called Y. All right. Next thing we do is we establish which features we're going to use to predict. In the next lesson, you're going to be able to start choosing your own features here. You can have as many or as few as you want, and you can use those to start making predictions. You can start playing around to see which ones are better and worse than others. And then here, we're going to actually grab those out of the table. So we say, hey, go back to that main home data table where all of our data is, and get each of the columns that are in the features list. So all of these columns, pull them out, and store them in a new data frame called capital X. Okay, and the machine learning requires that the predicted one's called Y and the features are called capital X. It's just, you have to learn that as you go through. All right, next thing we need to do is take this huge data set of stuff we're going to use and break it into a training and a validation data set, and that's what's happening here. So we're using the train test split function. We're saying take our big X data frame and our column of Y prices and break them into train test split. So it's going to create a training X, a training Y, a validation X, and a validation Y. Each of those are data frames with lots of data in them. Next thing we're going to do is we're going to grab the decision tree regressor. We're not going to set the maximum nodes on this one. We're just going to do it right out of the box, give it a random state of 1, and save that blank regressor tree or decision tree in the Iowa model. Then we're going to fit that Iowa model decision tree using our training X and training Y data. Once it's totally fit and ready to go, our next line of code is going to take the Iowa model that's already been fit and ready to go. It's going to use it to predict our validation X. Again, these are houses that the model has never seen before. It's going to predict the sale price of all those houses and then store that in a list called val predictions. So that's what the model thinks the prices should be. Then we're going to calculate our mean absolute error. And we're going to do that using the mean absolute error function. We're going to compare the predictions to the actual values for the homes. It's going to subtract the two numbers for each house, take the absolute value of them, and then take the average of all those absolute values. And then store that single number in the end, that average, in a variable called val MAE. All right. Next thing we're going to do is just print that on the screen. So we're going to print the words validation MAE when not specifying max leaf nodes. And then after that, it's going to actually print this. All of this stuff here is for this format thing to tell it how to format it. Let's not worry about that. We won't use that on our stuff. All right, next thing we're going to do is we're going to take a step back and we're going to redo the Iowa model. This time we're going to store in a decision tree regressor, but we're going to tell it to limit the max leaves to 100. And in fact, we know the real number is 71. So I'm going to put 71 in for the actual real number here, still random state 1. So basically what it's going to do is take the model that was already fit, it's in Iowa model, it's going to erase that model and put in this new blank decision tree regressor with a max leaf nodes of 71 into that thing called Iowa model. All right, now we're just going to refit just as we did before. We're going to use our same training X and training Y data, and we're going to fit the model. This time though, we're going to limit it to 71 leaf nodes instead of more or less than that. And then we're going to use that fully fit model now, that newly fit model, to do predictions with. And we're going to predict our val X data, store it in the val predictions. And then we're going to do the mean absolute error comparing our predictions to the actual values and store that average of all of the error in the val MAE. It's a single number. Then we're going to print that single number for max leaf nodes. And then we're going to do that same formatting stuff and then print that same thing. Now it looks like this one has our old mean absolute error. When we do it again down here, because it's a variable, it deletes the old one and puts the new one in place. So a little confusing that they use the same words all the way through here, but that just means that we're losing the old model and replacing it with the new. And then this last little bubble is just like always, it just sets up the notebook so it can do testing and checking to see if the code is correct. All right, we'll let that run and see what we get. Okay, so it's all done, ready to go. Our MAE, when we're not specifying any max leaf nodes, is 29653. When we do it just right, we get a 26704 when we have the 71 set. All right, awesome. That so we made it much better by choosing the correct number of leaf nodes, but we can make it maybe even better by using random forest. And so now this is our kind of baseline. Can we get better than these two? All right, so using random forest. So we're going to use we're going to rename our model RF model to identify it from the Iowa model above, and we're going to come up here and we're going to say random forest regressor. So that's the function. I'm going to copy and paste it from here, and we're going to give it a random state of 1 from up here, just like this one is. Random state of 1, and again that just keeps it that just makes sure it does it the same way each time. So now we've brought the blank model over, we stored it in a variable called RF model, and now we need to fit it. So we're going to go RF model dots fit, and we're going to fit it using, just like up here, our val X data, comma val Y data. That's not true. We're going to use train X and train Y. That was terrible. I'm just going to copy it from right there. Sorry about that. We'll use our validation in a second, and that should be Y. So RF model fit, train X, train Y. All right, so now we fit the model, and now we need to make our predictions. Oop, except I think I put it in the wrong place. It's asking for it to be right down here, although it doesn't really matter where it is. We're going to fit our model right there. And now we need to do a prediction. It doesn't say really where to put that, so let's put it here. We're going to do RF model dot predict. So again, I'm going to just copy and paste to avoid typos. Predict, and we're going to predict using the validation X data. And we're going to save that. So we're going to get all this whole list of predictions into, I don't know, something called RF predictions. RF predictions. Yep. Awesome. And again, those are all our choices of what to call this stuff. And then the final thing is we need to calculate the RF val MAE. So this is the mean absolute error for the RF model. And then, in fact, I'm going to change val. You don't have to. I don't like val in there. I mean, it's the model prediction. So RF model MAE. Because the mean absolute error refers to the whole model, not just one value. So I think that makes more sense to me. Here we're going to use the mean absolute error that we had this function up here. And to do this, we're going to compare two things. We're going to compare the RF predictions. And it doesn't matter what order these things go in. And the validation Y data. So this is the actual data, and this is our predictions data. You could have put val Y first in RF predictions because it's the absolute value. If they're negative, they're going to be positive anyway, so it won't matter which way you go. We're going to store that into this, and then we're going to do, oh, we changed this, so we're going to do this to model. And, oops. And I'm actually going to get rid of this dot format, put a comma in. I'm going to get rid of these, and then I'm just going to get rid of this here, and then I'm going to put a $sign right there. RF model MAE. All right, and now we're going to run. And I'm going to actually put a round in here. That's a good function to remember that almost always exists. Put another end here for the if statement. Round, put an I in there somehow. RF model RAE, yep, MAE. I'm going to run it again to see if we get a rounded number. Yeah, we got down to 21,857. Remember before we were at 26 at the best. So right here, by doing all that work to specify the right number of leaves, we came down like 3,000. Here, just by using the random forest regressor, we came down by like 8,000 by doing that. So the random forest is a much more powerful tool than the decision tree regressor, even when the decision tree regressor is optimized for the number of leaves. Okay. All right, that's it for this lesson. Good job. You're going to take basically this bubble and you're going to import it into Google Classroom and answer some questions about that. Great job.